Hi, my name is Juan Carlos Fuertes Otoya. I'm a student at the Catholic University and I study in the career of Electronic Engineering in Control and Automation. This project has a title interfacing and PCF8591 ADC DAC module with Arduino. Definition: Analog to digital conversion is a very important task in onboard electronics as most sensor provides output as analog values and to feed them into a microcontroller that only understand binary values. We have to convert them to digital values. So, in order to process analog data, microcontroller need an analog to digital converter. Next, we will see a video that explains us better about the definition of the ADC or DAC.
The world of audiovisual is full of acronyms in serious need of deciphering. Two of the most common being ADCs and DACs, or DACs. The How to AV team is here to translate. ADCs and DACs, let's start by translating them into real words. And then we'll move on to explaining exactly what they do. ADC stands for Analog to Digital Converter, and conversely, DAC or DAC stands for Digital to Analog Converter. And in the world of AV, the signal we're converting with an ADC or a DAC is audio. Both devices do exactly what they say on the tin, but why might we need to use them? As an existing commercial AV or home entertainment system develops over time, the addition or replacement of certain component devices can result in a mixture and a mismatch of both analog and digital devices. For instance, the vast majority of audio amplifiers, from commercial PA amplifiers to high-end hi-fi amplifiers, will use traditional analog technology due to the pure, uncompressed sound it's going to produce. And if your audio system features older technology devices, such as a turntable or cassette deck for instance, then they're most likely to be analog. However, latest generation AV devices, the Blu-ray player, MP3, Sky TV and streaming devices for example, are all digital. So if you're looking to integrate an analog signal into a digital AV system, you're going to need an ADC, or analog to digital converter. And if you need to insert a digital signal into an analog system, the DAC, or digital to analog converter, is the solution. Thanks for watching, and don't forget to leave your comments and even more questions for the team in the comments section below. Join us again soon here at howtoav.tv as we make understanding AV as clear as the picture on an Ultra HD television.
PCF8591 ADC DAC module is a 8-bit to 8-bit digital or digital analog to an analog module, which means that it can read analog values up to 256. It also features LDR and thermistor circuit provided on the board. This module has 4 analog input and 1 analog output. PCF8591 interface module with Arduino. Interface of PCF8591 with Arduino is very easy. In this interface, for example, we will read the analog values from any of the analog pins and change those values to 100 potentiometer. First, connect VCC and ground to 5 volts and ground of Arduino. Next, connect to HDI and HCL to Arduino A4 and A5. Now connect a 100 pot with aim out as shown in the figure. For LCD, The data pins, the D4, D7 are connected to Arduino's D5, D2 digital pins, and the REs and EN pins are connected to Arduino's D12 and D11. LCD Vout is connected to the pot on a 100K pot, which is used to control the brightness of the LCD screen. Required components: Arduino Uno, PCF8591 ADC module, 100K pot, jump cables, breadboard, LCD 1602. In this video, there will be a physical presentation of the functionality of the module. Application in electronic engineering. It is an analog world controller with digital computers. As such, electronic designers of Internet of Things device need to efficiently convert analog values into sample digital representations. While the simple answer might seem too simple, put an analogy to digital converter ADC from not all ADCs are created equal. Therefore, electronic designers must understand the various topologies and how they are mapped to the application. For example, ADCs are designed to optimize characteristics such as sample rate, power consumption, and accuracy. This article will discuss the design required in the context of some common ADC architectures. First, it allows us to convert a signal, whether analog or digital, for the use of electronic systems we use in our daily life. Cons: these modes prove to be somewhat expensive for project quality, but most microcontroller arrays have an analog digital converter included. Use applied in Ecuador. It is common to see this type of converters in most electronic circuits. It can be said that this technology is used in almost most of our daily activities. For example, when measuring the temperature, and we see the result on a screen when measuring the voltage of an electrical voltage, and visualize it on a computer by controlling the illumination intensity of a bulb by means of a controller. There are several examples where MIT is used here in Ecuador. Conclusion: in a data acquisition system, the use of some hardware element is essential signal type converter. Thus, you have the option of using device that converts signals analog to digital and digital to analog. An analog digital converter is a device that converts signal continuous to digital encodings. Typically, it's an electronic element or circuit that types in their input the analog signal with amplitude and frequency restrictions, and their output with open digital values that can be present in different types of encoding. Thank you.